Hi everyone, welcome to Silicon Valley Quantum Computing Group's 25th session. Today I have with me Sri Kutan from Bloq. He's the co-founder and the CEO. We're going to talk about how global businesses can start with quantum without the headache. Nick. So first of all, about myself, my name is Taposh Roy. Last 4 years, I've been doing Silicon Valley Quantum Computing Group. I have learned a lot. I have now advised technologies, published about 5 or 6 papers now in quantum computing and machine learning intersection. I am at Harvard Medical School at the intersection of AI and ethics, and also I'm the author of the book Intelligent Governance, which is navigating AI and quantum as well as classical computing in this phase. Before we go, some of the major events happening in quantum computing. Um, so one of the big events are in black here. These are the August 31st, September 5th. We have the IEEE Quantum Week. Then there is another one in November, which is the European Quantum Technologies, November 10th to 12th. More recently, in the next few days, there is Quantum India Belagru, which is July 31st and August 1st, these 2 days. So if anybody's interested, um, IBM is hosting its third quantum simulation conference in its offices on August 4th to 8th. It's in New York. If anybody's interested, feel free to join there. And the major breakthrough happened this year around June, July, where the scientists were able to make the magic state real. I'm going to put the link, what is meant by magic state. All we need to understand is this is one step more closer to make the quantum computer useful, and we'll provide that in more detail. I'm going to give a high level agenda on what we are going to expect in today's talk. We'll have our guest speaker, Shikutan, talk about his topic, which is how global businesses can start with quantum for 20 to 25 minutes. We'll talk through this topic. I have a set of questions I want to talk to, get some input from Shikutan, so we will talk for the next 10 minutes. We'll open it up to the audience for more questions, and then we'll end the session promptly at 10 a.m. PST. That's the agenda to look forward. I'm going to introduce Srikutan. He is the co-founder and CEO of Bloq Quantum. It's a deep tech startup. He has a background in physics from IISER in Pune and has a hands-on experience. He worked with Kurishi. That's where I first met him. He is really smart. He's reviewed several research papers, filed patents. He's also taught sessions as well. His focus at Blog is to bridge the gap between cutting edge quantum tech and the business needs of the real world. With that, I'd like to stop sharing and pass it on to Srikutan to start sharing and take us through the journey.
Thanks, Taposh. Thanks a lot for the intro and the wonderful work that you've been doing with Silicon Valley Quantum Group. I've seen Silicon Valley Quantum Group, I think, from 2 years from now. And hi, Nardo. Glad you're here. Um, I've seen work that you've been doing and the consistent work of spreading how quantum computing is moving from lab to commercialization. So, excellent work. And thanks for actually playing that part in bringing quantum to the masses. So in that sense, note, I'll share my screen. I'll walk you through. Yeah, great. So how my screen is visible. I'll anchor. So the idea of the talk right now today is to ensure we have the context in business leaders, enterprise leaders, as the context on where we are right now and how we can start without the headache of complex quantum computing aspects. Because as most of you have seen, quantum computing is not a easy topic. It's not definitely not an easy topic for all of us to wrap our head around. And we usually would want really advanced skill sets to actually begin. But there has been a lot of improvements that have happened in the last 2 years, at least from last 3 to 4 years in terms of software, which actually helps businesses to start looking into quantum without the headache. And we are one of the proponents of that school of thought. And I would love to walk you through how we can start without much headache by giving you the context of why you should start right now. Okay, to start with, I would want to take you through what have changed at this moment of time. Just like Tabosh have mentioned, one of the breakthrough that you have mentioned about magic states, there has been multiple. There has been multiple quantum breakthrough that have been happening. For example, recently Quantinium came up with universal gate sets, which was the last piece of puzzle that we need to solve to make sure that we have um, every foundation set for making quantum scaling up. And then IBM came up with a white paper on quantum advantage, so that they're claiming they would say they would get quantum advantage by 2026. And one thing that has changed from last claims of IBM, so IBM has been claiming this for some time, we all know, right? One thing that I've been changing in that is the language that they put up, and also the facts that is supporting it. So if you read that paper, if you read that white paper that IBM have shared, they have pointed out real experiments done by IBM, their collaborators, and some other wonderful companies in real world quantum applications and looking into possibilities of advantage. So recently, IBM had some did something on chemistry, quantum chemistry, and different other companies have done multiple aspects to stress test the quantum computers that we have right now, and have really found promising state of results. That's one thing. And another thing that have happened is we are moving towards something called logical qubits. So people who are not much aware of quantum computing would have heard about qubits. Um, Now these qubits, as you would have also heard, they're really error prone. There are a lot of errors. They're noisy. If you do measurement, you won't get the right results every now and then. So you need to do a lot of post processing to actually make it good. Now they're making qubits which are error prone. They don't get erroneous easily. So that qubits are called logical qubits. We combine like roughly 9 qubits or so, but probably it can be seven as well. 7 qubits and then make a logical qubit. So the transition from physical qubits to logical qubits is happening again, which is something that is changing the course of the technology. And that is where I would want to say this is not 2020 or 2017 or even 2022 when there was a huge hype. There was a huge hype. Um, and the technology that have matured from 28, 22 to 2025, the delta is huge. And that is why we should really start looking into right now. IBM is saying 1 year. Optimistically, it can be 3 years. Realistically, it'll be 5 years from now. So we don't have much time to build capabilities. It's going to take at least 3 to 4 years to actually build the systems and build the capabilities that you want. So when I say capabilities, there are a few things that you need to keep in mind is once quantum goes mainstream, there is going to be a huge frenzy. Imagine what had happened in NVIDIA's case, like the generative AI case, ChatGPT happened. It is very difficult for you to get hands on NVIDIA's GPU now. It got really costly. So quantum computers will be much more scarce. Access to quantum computing will be much more scarce. There will be a lot of geopolitical things that will be happening, and then talent will be again scarcer, and then you can't take an off-shelf product or service and build it for your own. That's why you need to start looking into your own sort of problem statement to start building problems. So that is where the the gestation period for even your technology in quantum computing in your particular company will at least take 2 to 3 years to set everything up, want to make you have everything ready for quantum course mainstream. Few things that is aiding this transition is recently when I checked this year. This year, I think it is not yet just half of first half of 2025. It There has been $4 billion in private funding. $4 billion in private funding just this year. In total, it is around $15 billion in private funding in quantum technologies. Not just quantum computing. I'm talking about quantum technology as a whole. But in quantum computing itself, there is around two billion. So most of it is post IPO that would have been raised by IonQ, D-Wave, Rigetti, and the public companies. They have raised a crazy amount of money. Then quantum software companies, then uh, private companies, private quantum computing companies like Qora, Qora, quantum machines, and so on and so forth, right? And also more, uh, much more valuable thing is that government is also chipping in, and there are huge amount of early movers. That is 510 plus enterprise users currently have started looking into quantum computing. So this is all the biggest companies in the planet, all the biggest companies, all the financial companies, all the pharma companies, all the big names have done something in quantum. Believe me when I say that. I actually have the list of all these 510 companies. So all the companies have done something. So this is your chance to make sure that you don't miss the best. And then there is cloud-based quantum computing right there for you to start looking into quantum. So this is the start. This is the point that you should start looking into quantum and should not wait more. In that context, to just give a brief of how global landscape is evolving, North America is always a leader. That as we have seen across all the technologies, and that's how quantum is also going. North America leads in terms of startups, leads in terms of technological maturity, leads in terms of adoption, and also academic and industry tie-ups. Europe is actually trying to get their wave out, get their foot strong, but the recent policy adoption by the EU, European Union, wasn't actually uh, well um, uh, well accepted. There was a lot of backlashes because they're still saying 200 qubits or so by 100 qubits or so by 2030. So their ambitions are not that high enough. That's what the most of the entrepreneurs were saying. But they are still really, really good companies coming out of Europe. Like, for example, like Pascal, Alice and Bob, and so on and so forth. There are a lot of good quantum computing companies also coming from Europe. They are also good in quantum software as well. So they're also putting up their good effort. And then we have China. So the estimates are 15 billion by national government, 15 billion by Chinese government. That's what we know publicly. And you know how China behaves. So whatever happens in China stays in China. So we don't know what's actually how much is progress, what's the technology there at. So recently we got to know there was a 512 qubit system coming out of China. So we don't know much after that. And India, where I sit out of, we are late to quantum, but we are still putting our best foot forward. And I really see an accelerated phase that's happening in India right now. So really great kudos to the Indian government for doing that. Around $900 million is committed in India. So we have some really good quantum startups, quantum computer companies, then software companies like us coming out of India as well. So um, all there's going to be huge global competition in quantum economy as well. It won't be like generative AI wave that I've seen, predominantly dominated by you know the North America. I think it'll be more distributed. So hopefully the context would have been clear right now. This is a time for you to start looking into quantum, and this is where all the factors are being coming into right place. Now, how you as a enterprise would start looking into quantum. So that is where um, you should give me a second. Yeah. And these are the three, four steps that we usually suggest for any company. This is the roadmap that you could take. First is always make sure that your board is on board with your quantum agenda. That is the most difficult part, having the board discussion and getting that approval. And the best thing right now is that there is this technological maturity that's happening, and there is being a lot of abstraction that you could have done. And also, you have quantum computers right now on cloud. That's already out there. Hopefully, that would make the conversation much more easier. And now, foremost thing is to do the internal assessment. Very key on this thing because not all not all the use cases is right for quantum. So I would as a CEO of a quantum company or a quantum software company, I would say it's it it's in my best interest to say whatever use case here we'd be able to solve in quantum, but I won't say that. This is not the right approach. Not all the use cases is not right for quantum. There are some set of use cases in machine learning, in optimization, in simulation, which would be right for quantum. So these are the two, three key points that you should look into by checking if this is the right problem statement or not. One is your current machine learning problem not giving you right performance that you would require, like accuracy and so on and so forth? Second would be, is it taking a lot of time? Third would be, is it costing you a lot in compute power? So if this is three, four things that it is troubling you in different use cases, then we could assess quantum computing. Now, if you have found this, let's say four use cases, and from there you should find a low risk use case where you should not be looking into taking your confidential data set or different other things that you would want to have much um, access and permissions. Start with a low risk pilot. So that's very key because you already have cloud-based infrastructure out there, really good quantum software. I'll also come to just I will come to next point. I'll actually how to actually start doing something easily and with much smaller scale systems. So, for example, we already know uh, all the problem statements that you will have will be much larger in terms of millions and billions of parameters, features, and data set. So try to make that problem statement into a much smaller arena so that you could make sense will it work or not. And then do a pilot either. So I won't suggest to build a quantum team yet. You should try to find few champions in your organization who would want to really do quantum computing, let's say from machine learning or innovation team. And they should be the ones looking into it, and also partner with quantum focused platforms and softwares like where your entry point would be much much lower. You don't want to spend a lot, um, because it's already out there in cloud. The credits won't cost much. If you partner with the right people, it also won't cost much rather than building your own internal teams. So that is the three, four uh, roadmap that I suggest to start looking into quantum. And now coming to how to start looking into quantum computing or adopting quantum without much headache. Just like I mentioned, there is a lot of complexity in quantum, that if you want to do something in quantum, do a small POC, do a small experiment, it take a lot of expertise to build something. Now, there one other interesting thing that have happened last year at least, or more 2 3 years before as well, is there has been good importance and emphasis on quantum software as well. So so you probably already know Classic. So Classic was the OG quantum software company that I've started. And then there are multiple other companies which actually helps to make this transition much more easier. So because of course, I'm from Bloq, I represent, it's my company. I have access to Bloq, so I'll be able to show you how we can do experiment with Bloq much faster and easier. But that doesn't mean that Bloq is the only option. So there are multiple other options. So for example, Classic, they recently raised 110 million Series C. And then there is QBraid. Then there is Planck Q by Kipu Quantum. Kipu is has been doing really good work in quantum algorithm as well. And then Horizon Quantum, they're still in beta phase. They're still coming out. And then we have Strangeworks as well. There are good companies out there in quantum software that which actually helps you to start looking into quantum without much hassle, without much complexity, and without taking a lot of building a team, building a PhD, hiring a PhD, and doing through the headache. So all these platform, you should definitely look into all these platforms and see which is best suited for you. Because I have access to Bloq, and because of course I'm the CEO of Bloq, I'll say Bloq is the best platform. But don't trust me on this. Definitely do your background check. So what I'll do right now is that I'll actually take you through Bloq and actually show you how you as an enterprise customer could actually start looking into quantum much easier and faster. Let me, yeah. So this is a platform. So I haven't publicly put the platform out yet. So you will be the few set of people that have seen the platform and have seen the inner workings of it. Um, so the idea of Bloq is always how we start with this problem statement. How can we make this experience much faster and easier? We've already seen all the other platforms out there. We could know why they weren't the best experience and why they weren't the right sort of tools for enterprise customer. So now taking an example, taking a very random example because finance, we have been talking to multiple finance customers. That's why always finance problem statement comes to my mind easily. But it can be other companies, right? It can be any other things. That's why what we have done is our platform, the workflows, you could see machine learning optimization. So we have a machine learning workflow right now, and optimization will come soon. So when we say machine learning workflow, machine learning, whatever problems you have in machine learning, you could experiment in our platform right away. So you could give a simple title for that experiment, whatever you want to give. If it is a fraud detection, I'll just give you just say fraud detection, and then data set. You could actually then for a machine learning problem set, you'll have a data set, can upload the data set over here. And then once you upload, you could actually select what are the list of columns, and then what is the target uh, feature that you want, size of the data set, train the speed. Again, these are things that if you as a machine learning guy understand, we do all those things here as well. And then you can select which quantum model or quantum algorithm that you want to run your algorithm on, set whatever you want. We'll have four by the end of this week. So currently have two up and running. And then you can give the number of qubits, a qubit depth. And here device is where you'll get access to multiple quantum quantum devices. We call it QPU. So there will be multiple simulators, multiple real quantum hardware coming as well. So right now we'll give you access to IBM's device, IBM simulators, and then once you give all this access, once you simply click run experiment, you would have run a quantum algorithm without even writing a single line of code. So for an enterprise customer, this would actually save you a lot of time, right? Because you don't want to spend a lot of time testing or experimenting which use case would be right for you, which use case would give you good results. So here you could do that, and you could directly get the result. um, so this is the result like accuracy, reference score, precision, recall. These are the machine learning performance metrics that you as a customer would want. To do multiple experimentation, let's say this is a good result, 0.64 is something good for you, then you can click this button and you'll get the code for that experiment over here. So this is a fully fledged editable Jupyter Notebook interface. Um, Yeah, so this interface is fully hosted in our environment. We are super proud to say we have actually built this ourselves. This whole notebook interface, we have built it from ground up from ourselves. So this you won't see in any other platforms. They would have taken any other existing platforms and then they would have integrated that. And one of the good things that you can do whatever you'd want, you can continue building, can continue testing it with multiple classical models, multiple classical benchmark, can do everything here. One other good thing that we'll be providing is in the cluster that you'll be building, or the environment that you'll have for this particular notebook, you'll also get GPU. You'll also get GPU access. Not so you'll have QPU, CPUs already here. You'll also get GPU access. It is very, very crucial as you would have already guessed. Quantum won't exist in uh, quantum won't be the only part in a solution. It'll always be going to a hybrid solution. When I say hybrid, quantum, then GPU, and then CPU. So this amalgamation of QPU and GPU is going to be the next most important thing in your in your enterprise that is going to happen. NVIDIA is actually onto it, even though Jensen said its quantum is 10, 30 years away, but here NVIDIA has an NVIDIA quantum division and they're doing really good work. So I have really insider news about how things are going there. So yeah, NVIDIA is super into it, and this is how it is going to be in the future. GPU plus QPU. So that's why we give you directly the access to GPU right over here. So you don't want to worry about only having QPU. And then we also have something called Circuit Studio. The idea here is that there is still some parts of quantum computing that you still make circuits for. You could make circuit here, and if you save it as let's say some feature map or something, always the beauty of it will be it'll actually come in the experiments module under custom. So the idea would be it makes much more easier. So this part, classic circuit builder part, is for advanced customer, or a user who want to go in depth and build circuits. So this is much faster. You'll do what it's just change something over here, and you'll directly get the change circuit over here. You don't want to again do all this coding. So imagine if you want to do something like this, then you would have written all this code here. You can always get the code, then copy it and take it back the way. That's also possible. But if you want to do all these things, it have taken much more time. And mm, that is the whole end-to-end research that we do in quantum, and this is all that you do want to do. So that is how we actually help. I believe this is the best experience that you will get. Yeah, that I'll say because of course I am the CEO of the company. But we do believe this is the best experience that you'll get for building a quantum experience without much headache. Now, continuing my conversation on which industries definitely should start looking into quantum. Um, with the talks that I'm having, right? So we have been talking to customers and we have been seeing how the adoption has been going in real time. I've been mapping this quantum adoption for at least 2 years now. Finance institutions are into this from very, very early on, from very early. So, for example, like one of the crucial, one of the pioneering institution was HSBC. They have started, I think, 7 years back, and there are multiple other institutions that we actually don't know and would have had a quantum computing team as well as the finance institutions. There is going to be a huge impact of quantum for them, even though they are highly regulated. They're already in quantum. So if you are from finance institution, this is the time for you to start the discussion. Whatever bank you have in your mind, you name it, they'll definitely have a quantum team. And then logistics institution, like in terms of the manufacturing, aviation industry, where all this, where moving or travel combines. So it can be automotive, it can be aviation, can be shipping companies. That has also started seeing really good access, really good adoption. Then we can't forget about pharma companies, include healthcare companies and life science companies as well. Both of them are rushing into quantum. So one good um, resource for you to check this adoption would be you can go to something called um, Quantum Insider. Okay, Quantum Index. Quantum Index by Quantum Insider. So I was the person who actually built that for Quantum Insiders. While I was working at Quantum Insider, we built this index where we rank different companies on adoptions. Let me try to pull that up for you. Hopefully, I'll.
Just put the link for you. You can just click on it. Yeah.
Yeah, yeah, yeah. Okay. Give me a second. I think. Okay, that's great. So, I if you could search, let me. Okay, yeah, here it is. So I think the link would be index dot. Just search the quantum index. If I'm not wrong, you'll get that. So yeah, there'll be good idea about who are the companies who are leading this. And then also energy companies. One of the best example will be E.ON. They are an US-based company. They have done some really good work. All the big energy companies have started looking into quantum very, very enthusiastically. Also, key things that you should make sure that you don't do this while you're doing adoption is that there is really good value that is you'll get in the quantum. And you should not add that while you're doing your research. Should not set unrealistic expectation at this point of time. Should not overhype and then imagine, okay, if you spend a lot more on compute, we'll get huge returns. It's not like that. It starts small, then only build on top of it. And also very important, not all use cases are right for quantum. Again, I'm reiterating that not all use cases are right for quantum. Always, always, always benchmark it. Benchmark in every part of your quantum journey. It's very crucial. And that's why in our platform, we have that notebook interface for you to benchmark thoroughly all the time. You are the subject matter expert. You have your machine learning expertise. Benchmark it always. And then understand where the performance is coming, how the performance will be improving. Don't look for um, first improvement in running time. It'll come. It'll come. It'll come within at least 1 year. It'll come. And also don't look for right now improvement in computing power. It'll also come within 2 to 3 years. Also, if you're just starting out, don't try to build your own in-house tools or in-house team right away. Try to get your ML team and then try to have a talk with somebody who can help you out when this was a one-off project. We'll be a great partner for you to start this and help you in this journey. We'll be happy to do that. There are multiple other partners who will be happy to do that as well. And also make sure that you have KPIs right KPIs, right metrics to track for. So there is also this connection of how you connect this result into business metrics. That's also a discussion that you should have. Um, if this improvement is 1% right now with, let's say, 10 logical qubits. If you have 100 logical qubits, hopefully the time spent would reduce to 50%, and that'll save you, I don't know, 100 million. That sort of calculation will also be on top of your mind to make sure that your use case that you've selected is the one that will give much benefits in the future. So that's also one thing that you should have in your mind. So key takeaways would be, as I mentioned, don't need deep tech knowledge to start with quantum. Platforms like Bloq will help you run pilots 100% sure within weeks, not months. It won't take months. There are definitely different other platforms will also help you here. Always focus on tech success and then business value, not on the hype. Saying some other company, some other PR, don't focus on that. Just focus on your core value, your core tech, and then your business coming out of it. Make sure that you have good sort of capabilities to start building that capability initially. So that's also very important. Find that champions who would want to start looking into quantum. So that, and then upskill from there and then build a quantum team. The next step will always be build that, have the discussion, identify use case, slowly start running a pilot, use one of the low code platform that we have out there, and then find what will be the ROI in the future, and then keep on experimenting and build the capability. So that's all from my side, and we're also open for companies for beta access. So you can scan this QR if you're interested. We'd be happy to give you access as well.
Thank you, Shikutan. I did have a few set of questions for you. Some of them are technical. Maybe I'll park them for now from your this thing. Just FYI, we just published a paper yesterday, a journal paper on. I put the link there. So we did go through a lot of effort in developing the circuits, especially. So if your tool makes it easy, so that is great. We'll try to see how we can leverage that in our research work. So few questions. One specifically is your tool is enterprise product, right? Is that correct? Yeah.
Right,
So
right, right.
what are your strategies for convincing the enterprise leaders to adopt quantum when ROI is not really clear right now? Yeah.
Yeah. So luckily, if we would have started five, let's say 3 to 4 years before, then it would have been a slippery slope for us. But what is happening right now is that we don't actually want to um, convince them about ROI, convince them about quantum. So most of them are already convinced. So they're actually talking to 15 plus enterprise users at this point of time. And all of them has a quantum team.
Mm-hmm.
So there doesn't need to have a convincing for them. They already have a quantum team. That means, so when I mentioned that the number 510 plus customers,
Mm-hmm.
so that is the number of enterprise users who are already looking into quantum. Now, out of that, there are 200 companies who already have a quantum computing team.
Mm-hmm.
So that is how serious they are. And this makes it easier, at least to start, but for us as a company to start looking into and adoption for our product.
Mm-hmm.
But in the future, in 3 years, there is going to be a frenzy, and again, hopefully, they will come to us rather than we going to them.
So, so now that you talked about that many companies, I'll appreciate if you can give us a real world example of one use case which is being used. Yeah, that'll be good.
Definitely, right. So, one of the companies who are doing pilot with us, so they are doing simulations. So when I say simulations, so what they're developing is quantum machine learning models for simulating airflow in airflow through a mechanical interface for a vehicle or so. I don't know the technical aspect of it. What they were able to do was they were able to test different algorithm, two different experiments within minutes, other than which have taken, let's say, hours or days. So that's what they've done. So this is from our pilot customer. Now, if I want to talk about use cases that enterprises are looking for, there are a lot of them. So a company, one of the largest mortgage lender uh, of the world, in actually in US. So their use case is on cash flow projection,
Mm-hmm.
revenue cash flow projection, because there are multiple different parameters that will affect it, and they usually currently use Monte Carlo simulation,
Okay.
and it'll take weeks. Can we
Yep.
reduce it? So that's one thing. And then there is genomic data. Again, genomic data is huge, like huge amount of data, huge amount of features. They are looking into, so this is another, the IT company. So they're looking into seeing, can we reduce, um, yeah, can we find patterns in the genome, can we find patterns of disease?
Mm-hmm.
So there is wide variety of use cases are out there. So a lot of them are out there. I'll be happy to chat more on it.
Sure, sure. No, this is great. Um, so as you know, last 4 5 years we have also been working in this space and writing code as well. I'm impressed to see the new low code or no code options. So can you tell us how is that evolving in keeping in mind the changes in the quantum hardware? So for the users who are not aware, the underlying quantum technology, how the logical qubits are formed, has variety of players in it, variety of technologies in it. So I want to
Good.
understand from your perspective how you are planning to bridge that gap with low code.
So yeah, I'd always want to emphasize on the fact the low code aspect will be the only will will only be uh, keeping on going. There won't be no code.
Okay,
So it'll only be low code.
they'll always be.
I'll come to why it'll be that. Um, so the fact that there is multiple technologies, multiple hardware, multiple topologies, multiple different infrastructure that can run quantum computing hardware. There needs to have a software like this. It can be Bloq, it can be different other companies as well, right? Why this is important is that right now there is at least 15 plus companies that has a quantum computing hardware on cloud, and at least five different types of them.
Yep.
So when we say GPU, just NVIDIA, where there is nothing much you need to optimize your code for, right? So it's just GPU, NVIDIA. But it's not similar for QP. It is 10 different companies, five different types of it. Neutral atom trapped ion, superconducting, photonics, and so on and so forth. So how do you optimize the code for all of this? So
Yep.
there are multiple different aspects of that. So that you definitely would need a software like this to actually do all this in the backend. You don't
Mm-hmm.
want to sit and write code for each of this architecture and fine tune the code for each of this architecture. It would never make sense. So definitely you want a tool like this, which is low code, to help you abstract away all these complexities out of it. And that is where we have emphasis on multiple devices. You experiment whatever you want. We'll have the optimized version of building it. Now, why I say there won't be the evolution of low code to no code, like we have seen in app development, software development, like the lavables of the world,
Mm-hmm.
won't come in quantum. I don't think at least for 10 years is, let's say, a logistic optimization for DHL
Mm-hmm.
won't be same as logistic optimization for FedEx. They're entirely different company, entirely different parameters, entirely different inputs. It is not going to be the same. So you would need specific code to be written for your use case, only the initial aspects of building and making sure that you have everything set for quantum would be can be abstracted away using a low code platform, but the rest of it just can't be. You need to have that subject matter expertise to build specific solutions. So that is how it is going to evolve. So to give my take, how it's going to be evolved is that we'll have agents. So our plan is to do that actually. So we'll have again, agents won't do all these things. Agents will try to give you initial set of inputs that uh, you as a customer can tune further, and then you can take it from there. So let's say there'll be an agent for logistics optimization, then there'll be a different agent for pharma optimization, so on and so forth.
Got it. Got it. No, thank you. Thank you. Um, Two other questions I had. One is basically, is the biggest pitfall that you have seen from early enterprise quantum experiments, right? And how does your product help to mitigate that?
Right. So one thing that I've seen is that hiring, of course, they see quantum and they'll say, okay, we need PhD guys. We'll go for PhD. And when you hire a PhD guy, then you say, okay, they won't know how to code. Usually, this PhD people will be very good at some very niche things, and then they won't be in terms of generalist people who could do code. Of course, they will be able to spend some time and get that thing. So to start with, you won't need PhD. That's what I would always. When if you want to go in depth, definitely you'd want subject matter expert. You'd want quantum information theory guys. So and then the fact that you take a lot of time building this. One good example would be from our pilot customer. He was able to complete an experiment that would have taken him at least 3 4 days to build from scratch an experiment and then get the result. He was able to do within minutes, few minutes, 1.5 an hour, complete it, and then he's waiting for us to actually add more algorithms so that he can continue experimenting. So this fact that um, you'd not want a deep expert in your team to start building, and in terms of taking a lot of time, that is two things that we would be able to solve for you in the start.
Makes sense. Makes sense. One last question is about the quantum ecosystem in India. You touched about it. I've seen a lot of notes. There has been a lot of conferences, and I've been part of a lot of discussions as well. So, just want to hear from your perspective as a founder. How do you see the ecosystem in India?
Good. So last year I had an interesting talk with one of the highly regarded professors in quantum, um, and we were not that convinced that India is going to do something really good in quantum. It was December last year. But what I'm seeing right now, it's it have made us to take what we have decided, take what we have said that time. So just 6 years, 6 months from now. But to just give an example, Andhra Pradesh was one of the state in India is building a quantum valley, and they're already starting to put a quantum computer in their premises. Similar to that, Bangalore. Then we have Karnataka. So that's another state. So Karnataka is another state. They're also pitching for quantum. And just in their first slide, there was Quantum India Summit. If I'm not wrong, that's happening in Bangalore.
Mhm.
It's in Karnataka. Such a global event. Two Nobel laureates are coming. So they're taking it really seriously. I'm really, really glad to see that not just national government, state governments are also taking it really seriously. And the fact that recently quantum computing startup called QPI AI have raised 32 million in Series A.
Mm.
So I know this is not a huge money for a quantum computing company, but still it's huge money for a quantum startup in India.
Mm.
So the wave is changing, the progress is happening, the pace is picking up. We have the number two. We are the second most. quantum talent in
Mhm.
all of the globe. Apart from Europe, we are the second. And we have the initial set of push from quantum. We have initial set of startups who are doing good work. I'm glad to be part of that ecosystem, and I'm 100% sure we'll be able to continue this good work and be the top three, four at least within 10 to 15 years.
No, thank you. I'd like to invite Nardo actually from Qubits Ventures. I know Jishnu from Nexus had to leave, but Nardo, you want to add anything? I saw your note here.
Hi, Nadu.
Hey, Srikitan, good to see you again and to push. Always good to see familiar people deep into quantum, right? So awesome. Yeah, so as you guys know, I invest in four areas. Future of compute, of course, quantum is hard smack in the middle of that, right? So future of compute, data, intelligence, and infrastructure. And a big part of the fund is building regional studios across the globe. So India happens to be the first one that we're building in. So the whole premise of it is, India has a lot of interesting companies and talent, similar to like Srikutan, right? Srikutan is actually, I've met him, gosh, maybe a couple of years now, Sri.
Yeah,
Right.
yeah. While I was working
And
at Krishi.
yeah. He was still working at a different company, and I could see a lot of promise there. And then India as a country is very interested in uplifting sovereign technology and uplifting their place in hardware, so especially in the semiconductor side, right? So I think India is already a powerhouse on the software side, and so having a venture studios like this focusing on quantum and advanced computing and everything else it impacts, I think it's a good move over there. So the market is massive. India wants to be part of a global ecosystem in this space, and that's what we're helping them to do.
Nardo, while you are there, I also am aware of there's a lot of work in the Philippines as well, and there is a conference going on in next week actually in Philippines as well. You
Yeah.
want to add anything from your experience there, or?
Ye- Oh yeah, this whole venture studio stuff is, so far I've asked, 14 different countries to push, and I'm batting 100%. So, so the interest to build in this area is very strong. I think a lot of it has to do with sovereign technology, right? So, I'm actually going on the flight tonight to Philippines and Thailand because they both have quantum summits. So Philippines is doing its first one. So I'm keynoting that one, and then I'll be doing an investor panel on quantum and advanced computing in Thailand as well. So Thailand, both countries are interested in building venture studios.
Awesome, awesome.
Nice.
Hello. Thank you for joining and sharing your insights here. It's always good to get a bird eye view from the investment landscape as well. So you bring in a lot of value, Nardo. Thank you. Thank you.
Oh, you're welcome.
Yeah, with that, I'd like to open it up. We have 7 minutes remaining for any questions. I know there was one question on the audience on the energy question. I just want to clarify when you say energy consideration, is this the energy the quantum computer takes, or is this like the Department of Energy was here in one of my talks here. Rima was here and she talked about how Department of Energy in US is looking into the quantum computing. But you want to unmute yourself and ask the question? It's from
Uh,
Jeffries from,
Hi.
yeah,
Okay.
yeah.
Yeah.
Go ahead.
Thank you. Thank you for the wonderful presentation. Actually, in the middle of the talk, this is Sri Kutan, right? See,
Yeah, yeah.
he mentioned that the I mean, there should be some field or some way the quantum computing is taking care of energy somehow. He just mentioned that word, and that energy is, struck my mind. That's why I was asking the question: how this
Definitely.
is applicable in energy consideration? How can we solve the problem of energy or something?
Definitely. Thanks a lot for the question. So, we all know the second biggest opportunity after generative AI in building all this NVIDIA is powering them, right? The energy sector. They're looking for nuclear reactors, nuclear energy sources right now, fusion and other stuff. So why that is there is how they compute is using just electricity, pure electricity, and that's what the voltage is. That's the base of it. Now, when you come to quantum, the base of computing is not you pass different voltages and then do different stuff with that. It's actually atoms, molecules, ions. These are just these are just subatomic particles which would not need all this huge amount of electricity to power them. They don't need this amount of electricity. So what they would require is, so if you do the math, it'll be like 10 raised to minus 6 joules or something for them to do stuff, right? So for them to do computation. So very small amount of energy that'll require to do computation. But they would require energy in terms of their control hardware. So they'll have a control hardware system, and that is where the energy requirement will come from. Now, if you compare the energy a quantum computer will take comparing to a GPU or a CPU, there won't be any match. It'll be uh, at least in the range of orders of tens or hundreds. That'll be there'll be minimum um, comparison would be that. So the amount of energy that a quantum computer will take would be much lesser than what a conventional system would take. So that is where we see there's going to be huge energy efficiency that we get from using quantum computing systems. We won't need whatever energy that we'd be requiring from for GPUs at this point of time. Again, I want to also caution it by saying this. So this is again more of a theoretical work. We can't compare. So we can only compare apple to apple once we have this quantum advantage. Once we do something in quantum computer and also do the same thing in GPU, and then compare it. At this point, in time, we can't do this, but theoretically, this is what is going to be possible. We haven't practically shown it yet, but we'll show it in the future.
Thank you. That was a good question. There is another question from Warren. Warren, do you want to unmute yourself and ask the question?
Sure, thank you. Yes, my question is, you have a workbench, lets people experiment rapidly, generate code, that's great. But when you come to the corporate world, and I've been dealing with this for almost 40 years, right? Now these days you cannot let any code run for a production system unless it's gone through a number of different security scanning checks, but also quality assurance. And also the big one is you run an experiment, then later on someone's asking you, well, what code could produce that result? You need to be able to, like, save these things, tag them, release them. So I get the fact that you have, scientists who are used to Jupyter Workbench going in there and just running a bunch of code, right? But from a production standpoint, what plans do you have to have your workbench deal with these problems that we see with CI/CD and SecOps and all these types of things?
Definitely. Thanks a lot for this question, Varun. So right now, quantum is at least as I've told you, 3 years is minimum that we'll have for quantum to go in production. Hopefully within it'll happen in 3 years. Realistically, it'll happen in 5 years. At that point of time, how our product will evolve is this our product will not be the same as you see it as of today. So this is catering for the catering for what is a need for our enterprise users right now. They just don't want to experiment with it. But they'll if they want to do production grade, it needs to have completely different infrastructure, just like you mentioned correctly. So they won't be deploying a Jupyter workbench or something, right? So in that essence, we know how it is done on MLOps. MLOps is MLOps is there, right? And there are different systems that needs to be built on top of it, like versioning the training models and save it as a trained model. all these things will have a version of that in quantum. And the biggest fact is that nobody have actually built that system. So we call it QC ops, quantum computing ops. We
Mhm.
are actually, we know how to build that. We'll take at least 2 years to build that. So once it is ready for you to do deploy and built in production, we'll have that system ready. So the idea would be you bring the data through data connectors through a data lake, probably Databricks or a Snowflake. You can connect directly to a platform. Again, all the security and compliances will be there for you to make sure it's secure. And then build that algorithm, connect your data, build that algorithm, and then you'll also be able to have an access to get an API out of it. They can build an API for that, and then can connect to your systems for deploying. And then you'll have versioning, multiple models saved, and then you can also track how it is performing. And then you can deploy it on multiple systems. So all this full environment, that is a plan for Bloq. So end to end. So you take your data, you build your systems, you deploy it on any of the hardware that you have that's of your choice. So everything will handle. Within 3 years, you'll have that platform which will handle everything, and then quantum will go mainstream, and then you can take your platform to build production grade quantum computing solutions.
Okay, thank you.
Thanks, Varun.
Thank you. So, Shikutan, I know we are at time. I want to be respectable of everybody's time, especially you are, it's late night, 10:30 p.m. for you on a
Yeah,
Friday.
10:30.
So thank you for your time. Really appreciate you coming here and talking about your vision, about your platform, and giving an audience an idea of how people can start into quantum computing. With that, I'm going to end the session. Thank you, everyone. The videos will be posted on the YouTube channel, and we'll take it from there. See you next time. Thank you. Bye.
Thanks a lot, Taposh, for inviting. Take care.
Thank you, everyone.